In this question, we're going to graph one cycle of the curve shown and also state the amplitude, period, phase shift, and axis of symmetry. Well, the first thing we often need to do when graphing a function that's undergone transformations is algebraically rearrange it, and we do that here. Now we can see what our A, K, D, and C values are. Our amplitude is the absolute value of A. A is -2, so the amplitude is 2. The period is 2 pi over the absolute value of K. Well, 2 pi over 1/2 is equal to 4 pi. And why are we using radians? We're using radians because radians are given in the question. Our phase shift is going to be 3 pi over 2 radians to the right. And finally, our axis of symmetry is at y equals 3. Now, we also, in our graphing questions, what we like to do is determine a key interval. It's not specifically asked for in the question, but for us, our key interval is going to be our period over 4. It's always period over 4. So in this case, that's going to be pi. Okay? So we've got an amplitude of 2 and a period of 4 pi, a phase shift 3 pi over 2 to the right, and an axis of symmetry at y equals 2. Okay, so our period is 4 pi, our axis of symmetry is at y equals 3, our amplitude is 2, and our phase shift is 3 pi over 2 units to the right. Okay, now what we have to do next is we ask ourselves, what is our parent function? And for us, our parent function is negative sine x. And the reason our parent function is negative sine x is because when we rearranged our curve in the last question, we saw that we had a negative coefficient in front of the sine. So our parent function is going to be negative sine x. Now, we always are going to have 5 key points, and the x-coordinates of those 5 key points are always going to be d, and then d plus 1 key interval, and then d plus 2 key intervals, d plus 3 key intervals, and then d plus 1 period. It always works out that way. Okay, so that's useful information to have. Now, in terms of our y-coordinates, we want to say to ourselves, well, of these 5 key points, which I'm exaggerating here on that little graph, which ones are on the axis of symmetry? And I would say the first, the third, and the fifth are on the axis of symmetry. So those are all going to have y values equal to c. In other words, the y value of the axis of symmetry. Well, let's look at this second, that second y value, that second key point right there. What's its y value? Well, that's 1 amplitude below the axis of symmetry, so it's c minus an amplitude. And how about that fourth key point? What's its y value? And its y value is c plus an amplitude. So these are our 5 key points. Okay, well, our phase shift represents our d value. So our phase shift, our first x-coordinate is 3 pi over 2. The c value is the y value of the axis of symmetry, so that's a 3. So we have one of our key points. Now, to get d plus a key interval, since our period is 4 pi, that means our key interval is equal to pi. Well, we're going to call pi 2 pi over 2. Pi is the same as 2 pi over 2, and we're going to do that so that it's easy to add to this 3 pi over 2 here. So when we say what's d plus a key interval, we're saying 3 pi over 2 plus 2 pi over 2, we're getting 5 pi over 2. For our next x coordinate, it's d plus 2 key intervals, so it's 3 pi over 2 plus 2 pi over 2's, which is 7 pi over 2. Our next x value will be another 2 pi over 2 radians away, and our final x value will be the original phase shift value, the 3 pi over 2, plus an entire period, which is 4 pi. Well, 3 pi over 2 plus 4 pi would be the same as saying 3 pi over 2 plus 8 pi over 2, which is 11 pi over 2. Okay, so we can figure out that last x value that way. But as I'm sure some of you have noticed, all we're really doing is once we figure out that first x value, the x value of the first point, every other x value that we have to get to, it's pretty easy to determine. We're just adding the same thing every time. Okay, because each of those key intervals is equally wide. Now, our c value is 3. Now, our second point is going to be c minus an amplitude. In other words, it's going to be 3 minus 2, which is 1. And then our third key point, and it's a little tough to see now, but going back to this graph right here, that third key point, the one I'm pointing to right now, that's back on the axis of symmetry. So it's got a y coordinate of c, which is 3. The fourth key point is that maximum point right here, and it's got a y coordinate equal to c plus an amplitude. 3 plus 2 is 5. And finally, that last key point is back on the axis of symmetry. It's got a y coordinate equal to 3. So now it's graphing time. So forgive me because I don't have a ruler here, but I draw my best x and y axis. Whoops, not the best. And then I see here the lowest common factor of all my x values is pi over 2. So I'm going to let each one of these squares represent pi over 2 radians. Okay, so the point 3 pi over 2 comma 3, and I'm going to let each one of my y, the lowest common factor of all my y values is 1. So I'm going to let it be, I'm going to let the index on my y-axis be 1. So if I want to go to 3 pi over 2 comma 3, I end up right here. Then if I want to go to 5 pi over 2 comma 1, I end up right here. 7 pi over 2 comma 3 is right here. 9 pi over 2 comma 5 is up here. And finally 11 pi over 2 comma 3 is back here. And now what I do is my best attempt at graphing a sinusoidal curve that goes through each of those points. They're not straight and rigid. They look like that. Now, that's the final answer because the question asked us to graph one cycle. But just for kicks, just to show you that this curve actually, because there's no restriction on the domain, this curve is actually doing this infinitely in both directions. And that's something that's important to remember when we get into word problem questions later on. That curve goes infinitely in both directions.